So in this video we're going to look at how to find the tangent to a curve using differentiation. Now we need to remember what we mean by a tangent. So I want here the equation of the tangent to y equals 2x cubed plus 3x plus 7 at the point with x coordinate 2. So I've just drawn a little sketch of what this function looks like here, and so we're saying the tangent at x equals 2. Now remember, that's a straight line that touches the curve at the point here at x equals 2, and it has the same gradient as the curve. It's not going to go through the origin here, but we'll work out where it goes. And so that's what the tangent is, a straight line whose gradient is the same as the curve at that point. So if we can work out what the gradient of the curve is at this point here, then we can know what the gradient of the straight line is. It'll just be the same. And differentiation gives us a formula for the gradient of the curve at all the different values of x. So what I need to do here is to differentiate this function. So if this is y, then we get dy by dx, and dy by dx is 6x squared plus 3. Go back to the videos on working out dy by dx and differentiating if you don't know how to do that bit. So that's dy by dx, and now so this is a formula. All the different values of x, it tells us what the gradient is. You can see here it's 6x squared plus 3, so actually this is always positive, and we can see that's kind of true in the shape of the graph here. The gradient is always going upwards. It's not, some cubics will have turning points and they'll go up and down, but this one goes up everywhere. And when x equals 2, dy by dx, well, that's what we get. We have to just put 2 in here, so it's 6 times 2 squared plus 3. So that's 6 times 4 is 24, plus 3 is 27. So that's the gradient of the curve at that point. Now this is a straight line. Okay, so we know that the formula for a straight line, so the formula for the tangent, is going to be of the form y equals mx plus c. And we know what this m is because we've just worked it out. The gradient of the curve is the same as the gradient of the tangent at that point. So actually this curve is y equals 27x plus c. So all we need to do is to work out what c is, and we're done. Now, this is a slightly tricky bit, I suppose, but because we don't really know, we can't work out where this crosses the axis, directly yet, but we do know one point which is on the line, because where it touches the curve, you see that point is on the tangent and it's on the curve. So if I can work out the coordinates of this point here, and we know the x coordinate is 2, so we just need to work out the y coordinate, then I can work out what this value of c is. So now the coordinate here is given by what we get when we put in the y coordinate when we put in x equals 2. So y will be 2 times 2 cubed plus 3 times 2 plus 7. So that's 2 times 8, that's 16, plus 6 plus 7, that's 22, that's 29. So that's the y coordinate at that point, it's 29. Right? So we know that that point there also lies on this straight line. We can see it's there on the straight line, it's where they touch. So these values of x and y that obviously worked here for x and y also have to work in our equation for the tangent, right? So let's put in x equals 2 and y equals 29. We get 29 equals 27 times 2 plus c, so that's 29 equals 54 plus c, so that means that c is 29 minus 54, so c is minus 25. So we've got our final answer then, which is that the tangent is has equation y equals 27x, and c is minus 25, so it's y equals 27x minus 25, and we're done. So recap that method. We work out the gradient of the curve at the point we're looking for. That gives us the m in y equals mx plus c for the straight line. We work out the coordinates of the point where the curves touch, and we use those coordinates to find out c in y equals mx plus c by substituting them in and rearranging for c. Okay, let's do another one. What about the equation of the tangent to y equals root x plus x squared at the point with x coordinate 1? Again, I've kind of drawn roughly what this graph looks like. It's not especially pretty one, but it looks like that. And so at x equals 1, again the tangent is a straight line that's going to meet the curve at that point. It's going to just touch there, and it's going to have the same gradient as the curve at this point. So we'll go through the same steps. I'm going to work out dy by dx, and now here, to work out dy by dx, we've got to just remember that this is x to the 1/2 plus x squared. So because of the indices, this is going to work out a little bit harder. So we're going to have 1/2 x to the minus 1/2, and then 2x differentiates to, x squared differentiates to 2x. So it might be helpful to rewrite this as x to the minus half is 1 over the square root of x, so this is 1 over 2 times the square root of x plus 2x. So at x equals 1, dy by dx is equal to what we get when we put in 1 to this, so 1 over 2 times the square root of 1. Now the square root of 1 is just 1, so that's just a half, plus 2 times 1, so it's 2 and 1/2. So let's write that as 5 over 2. So that's the gradient of the curve at this point, and so it's also the m in y equals mx plus c for this straight line, which is the tangent. Okay. So the straight line is y equals 5 over 2 x plus c. We've got to go through the steps again. We want to work out the coordinates at this point, and we know it's got x coordinate 1. So when I put that into here, I get y equals the square root of 1 plus 1 squared, so that's 1 plus 1, that's 2. So the y coordinate is 2. So this point here where they meet is 1, 2. So there are our x and y values for a point that's on the curve and on the straight line. So those 1 and 2 work for this straight line. So we've got 2 equals 5 over 2 times 1 plus c. It's just times 1, so I don't need that. So c equals 2 minus 5 over 2. So that's 2 minus 2.5. That's minus 1/2. So we've worked out that the equation of the tangent here is y equals 5 over 2x. C is minus 1/2, so it's minus 1/2. And you might want to tidy this up, rewrite this in a slightly different form. If we multiply it by 2, we would get 2y equals 5x minus 1. Anything like that. These are all equations, different ways of writing that same equation of the tangent to the curve at that point. So to be really good at these things, to really do well at A level as well, you've got to be good at the method, the technique, do examples like the first one where the algebra worked out neatly, but also then to be able to deal with these harder ones where you've got to also deal with things like surds, converting into indices, dealing with fractions effectively as well.